Hello, MTC people. So I made this this document here that can help you with Balkan's final project, and I figured I'd just make a little video to show how you can analyze the data in Jasp. Read this stuff before you get to the video because you might not understand what I'm referring to and talking about if you don't. Anyway, so let's suppose we did our experiment, and I'm going to show you how you could analyze the fake data about a fake study to answer the research question. Here it is. Does calling students' parents before a test to ask them to study intervention help them score higher on a test or quiz observation? So I have put a link to the data here. You should be able to just click on it. And from here, let's talk really briefly about the data. So just assume for a second that I involved all of my 70 students in the study. So it goes all the way down to student 70. You need to put the actual names of your students in there, though. That's just so you can keep track whether you called their parents and what score they had. So then there'll be two columns, the parents called column and the test score. So for instance, student 1, I put a 0 for parents called, and that means 0 means the parents were not called. So for student 1, I didn't call the parents, and their test score was 74. For student 2, I didn't call the parents, their test score was 37. If you scroll down, you'll see, oh, the scrolling doesn't want to work. If you scroll down, one sec, I gotta get the scrolling to work again. Okay, if you scroll down, you see starting with student 36, the experimental group starts. So these are the students who I did call their parents. That's why the 1 is here. Okay, so you have to convert this into a CSV file to analyze it in Jasp. So go down to download and file, comma separated values. That's a CSV file. Okay, it's downloaded. Then we need to open Jasp. Okay. One sec. Okay, here we go. So go to the menu bar here, click Open, Computer, Downloads, that's where mine put the download, Fake Data, Sheet 1. Okay. Open, and boom, there's our data. Okay, now what we want to do here, remember the idea is we want to know our students whose parents were called, are they doing better on the test than students whose parents were not called? So the simplest way to do this is to, let's start with, let's go to t-tests to do this, and we need to use a independent samples t-test. That's always the t-test you use if you're comparing two different groups of students. So in this case, we have the control group, parents not called, and the experimental group, parents called. So that's two different groups of students. That's why we have to use the independent samples t-test. Okay, so we click on that. Now let's see. This here says grouping variable. Well, we group them based on whether their parents were called. So let's click on parents called, and then this arrow to move it into the grouping variables field. Okay, and then variables. This is what we're actually like comparing them on, and we want to compare them on their test score. So we click test score, and then this arrow to put that there. Okay. From here, we want to see descriptives. That just means we want to see descriptions of the two data sets. And I'm also going to click effect size. Okay, so let's look here. This is the results of the t-test. Don't worry about the T or the DF, degrees of freedom. He didn't teach us how to do this, and from what I can tell, watching some YouTube videos, it's very complicated to understand what they actually mean. What we want to look at are these things right here. So the first thing, well, this thing in particular, the first thing we want to look, actually, no, let's not look at the t-test yet. Let's look at the descriptives first. Okay, so here we go. Group 0, N, that means sample size of 35. There were 35 students whose parents were not called. Their mean or average score was 44.943, about 45 percentage points was their average score, so pretty low. The standard deviation, that's a measure of how spread out the scores were. So, you know, if they all scored the same score of 45, standard deviation would be 0 because they wouldn't be spread out at all. If there was a large variety, you know, some scored 0, some scored 100, some scored around the mean, the standard deviation might be like might be as much as I don't know, 35, 40. This one's kind of in the middle. The standard deviation is 26. Okay, and don't worry about that. Okay, the group 1, that's the group with whose parents were called. There were 35 of them, and their mean or average score was about 58. And their standard deviation was a little bit lower, interestingly. And I just made up this data, by the way. I used a random number generator to come up with the data, but I did make it so that the students whose parents were called would have a higher mean score. Okay. So just looking at this, it looks like there's a pretty big difference, right? The students whose parents were called scored like a lot higher. They scored about, what is that, 45 to 58. They scored about 13 points higher. Okay, so now we need to know if this result is a true result or if it was just due to chance. It could have just been an accident that those students did better. It could have just been an accident. You think about when you flip a coin, a fair coin. If you flip it 100 times, you know, the probability should call for there being an outcome of 50% heads, exactly 50 heads, and exactly 50 tails. But we know in the real world, you know, there's some variation. It probably won't come up that way, actually. It'll probably come up like, I don't know, maybe 52 heads, 48 tails, maybe 55 heads, 45 tails. The point is, that's not exactly the same. So you need to do a sort of statistical test to tell you if the coin is really fair and it just kind of was different because of an accident. Well, we need to do the same thing here. Were their average scores different just because of an accident of chance, or are they different because there's really a difference between the two groups of students? And that's what we look up here for. We have to look at this thing called the p-value. That's important, the p-value. So p-value is basically telling you the probability that your results are the result of chance and not a real difference. So let me write here on top of this real quick. We want p to be less than 0. This is difficult to write with the mouse, 0.05. Okay, now listen, this is totally arbitrary. 0.05 is a probability of 5%. It's just saying that we want there to be less than a 5% chance that these results, this difference between the groups, is because of chance. And if we look at our p-value, it's 0.024, about a 2.4% chance. So that means that it's really unlikely that the difference between these groups of students is due to chance. It's more likely that they really are different because of something else. So and the way we put this, the jargon for this is that the results are statistically significant because the p-value is low enough. Okay. So we'll have to write that in. I'll put some more in the document about how to actually write that up into the presentation. Cohen's d here, that's what's called the effect size. This is just a measure of how big the effect is. And you'll recall from what he's told us in the lectures that an effect size of this magnitude, about 0.5 is, or 0.6, is a moderate effect size. But I'll put in the document that I'm writing up how to interpret the effect size, what's big, what's small, what's medium. So this is a moderate effect size. So viewing this, you could probably conclude in your discussion that it makes a pretty big difference calling students' parents, that it makes a pretty big difference. Since that's a moderate effect size, and just looking at the means, they are really different. It looks like those students whose parents were called did a lot better. Okay. Hopefully that helps you to use Jasp if you end up doing the kind of research design that I'm writing about in the document for you all.